Hello and welcome everybody to Kubernetes online masterclass series hosted by Rancher. Good morning, good afternoon, and good evening, depending on where you are joining from. We had over 1,000 people registered. This is second in the series and second time that we got over 1,000 people registered. And we are expecting several hundred to join. So this is a new series. This is number 2 that we are doing. Each class in this series is about an hour long, and then we give 30 minutes for Q&A. But while the class is going on, we try to answer as many questions as possible on chat as well. So the topics in this series that we have started, it includes things like migrating existing applications with Kubernetes, which is for today, Prometheus support, troubleshooting Kubernetes and how to run databases in production on Kubernetes, security, building cloud native CI/CD, and many, many more. Now, you must be wondering, why are we launching this series? Well, we talk to about thousands of users every month. We go to DockerCon, KubeCon, we go to all the industry conferences, we do meetups. And what we hear from customers again and again are common challenges as they deploy and scale their Kubernetes environments. Irrespective of the industry, irrespective of which company they're working for, which geo they are in, we always find that some of these challenges are fairly common. And all the topics that we choose, those align with those challenges that we keep hearing. We also have an open Slack channel. So if you're not on that, that's also a great resource for you to go and join. I'll mention that toward the end. And we get a ton of questions that we try to answer over there. And then finally, we think that there are n number of resources on Kubernetes. There are tons of resources on Kubernetes. And if you know where to look and if you know what you're looking for, how to get started, then there is enough information out there. And it's all available, it's all free. Unfortunately, what we find is that a lot of people struggle understanding where should they start, what exactly should they look for, out of all these free resources, which ones are worth it and which ones are not. And hence the series. We think that we can bring relevant information to you, to the point, something that really matters in our experience, and you can get started really, really quickly. So today's topic is migrating existing applications to Kubernetes. And I will introduce you to our speakers. Here are some of the other classes in the series in case you are wondering. We have migrating existing applications. Today we are gonna get into container sandbox next week. We are gonna talk about Windows, and then security, which I think will be very interesting one as well. And we have many more. There are these are just the few in the next month or so. Okay. Our speaker today is Chris Irwin. Chris has spent over 20 years working in the enterprises, helping them to implement new technology and working with teams to ensure that processes are adapted to cope. And in a nutshell, Chris is our director of field engineering. He basically goes into customer environments, sees what they are doing, figures out how to make any technology useful for them. And for last several years, he has been working both with Kubernetes as well as Rancher, and has very deep expertise in cloud computing, containers, and Kubernetes. So he's a great speaker, a great person to ask a lot of questions about. Every time he goes to the customer, he hears these questions that I have my existing apps, what do I do with them? Can I migrate them, or do I have to change something? And that these are the questions that keep coming back again and again. So we thought it'll be a good topic for Chris to cover. And my name is Ankur Agarwal. I'm head of product management here at Rancher Labs. Basically, my job is to define new capabilities, collect a lot of customer feedback, understand what you guys are doing, what problems you are facing, and then create products that are useful. Prior to joining Rancher, I built and ran Cubeship.io, which was an accelerator focused on container delivery. And I've been in DevOps and cloud computing for about a decade. I've built several cloud products for companies like VMware, Mercury, and now, of course, for Rancher. I'll be answering your questions along with one of my other colleagues, Matthew Shear, who's on mute. And I'm also going to be the host of both this session as well as some of the future sessions in this series as well. So some housekeeping that I'll do quickly before I pass it on to Chris. We always run over, and primarily because there are so many questions. So questions are always welcome. The more you ask, the better it is. There are no bad questions. We have heard everything. We have received everything. We have heard people asking us, how do I talk to Kubernetes to my managers? How do I explain it to the people who work for me? How do I position it? How do I sell it internally? Like, we have heard everything from technical to positioning to marketing to, how to convince someone in your team that Kubernetes is actually a good solution. So we try to answer as many of them as possible. But if we can't get to your answers and get to your questions, then please forgive us and join another session, and we will try to answer it then. All right, that's about it. And with that, I will pass it over to Chris. Chris, please feel free to take it away.
Okay, can you make me presenter, please?
Absolutely. Let me stop. And I'm making you the presenter now.
Okay.
Here you go.
Fantastic. You should be able to see my screen now, yeah?
Yes.
Fantastic. Okay. Thank you for the introduction. Hi, everyone. To those of you who are new to Rancher, welcome. For those of you who've attended sort of one of our online meetups or the previous masterclass, welcome back. Hopefully you'll find this one as informative as you have the past presentations that we've done. So as Anka said, I spend my time going in and sort of helping enterprises basically take advantage of containers and now Kubernetes. I've been with Rancher for 3 years now and have been into a lot of organizations. And like he says, we're sort of trying to address common scenarios with these masterclasses. So this one, it's not going to be deeply technical because a lot of the challenges of migrating existing applications to Kubernetes aren't actually technical challenges. I am going to go through some technical things and sort of technical checklist almost for things that you need to consider when you're migrating and things to watch out for. And then I'm going to go into a little bit about the processes. So just get my presentation going. Okay. So I'm going to discuss drivers. So what's driving you towards Kubernetes? Then going to talk about the technology and things that you can do with the technology and where sort of what you can do with containers and how to some of the things you need to look at on how to get them from your existing infrastructure into containers. So moving those applications. And then I'm going to talk about the difficult things. So the difficult things for me are always the wraparounds. Technology is easy, as all technologies will tell you. There's nothing really that money won't solve when it comes to technology. But actually, there's a lot of things when you go into the enterprise that start to become very challenging when trying to implement new technologies into the organization. So I'm going to talk about some of the common problems that we hit with those and the sort of departments that you need to talk to. Okay, so why do you want to migrate? What are the drivers in wanting to move towards containers? So everybody's heard about the hype of containers and sort of some of the benefits that they bring. So the first one really is it drives people is the faster upgrade. So in organizations, they may already be agile in the way that they develop and sort of delivering applications into full fat VMs or bare metal servers. But actually containers can spin up a lot faster. They're a lot more versatile and they allow for sort of a quicker evolution of your application. So one of the primary reasons that we see people wanting to move towards Kubernetes is that they want to take advantage of this faster life cycle all within the DevOps and Agile movement. And basically, they just want to do things faster. Another thing is portability. It's not necessarily between clouds, but also between platforms. One of the great things about sort of Kubernetes and containers is all of the things that you sort of produce, all of the containers that you produce, sort of they're pretty much agnostic to the underlying operating system. They don't care whether they're running in the cloud or in a VM or on bare metal. So the portability is one of the things that drives people. So as we know, increasing costs and running your own data centers is sort of on the decline. We still have some organizations that have to do this for regulatory reasons, but there's sort of an increasing move towards the cloud. And one of the things that people are keen to do is not get tied into the specific APIs of a particular cloud provider, because that then becomes a barrier for moving between cloud providers. So when you've got price sensitivity as it is, and you've got sort of the AWS and Azures of this world sort of fighting for people's business, and they reduce prices or increase prices, that can be one of the factors that influences people to want to move between clouds. So what Kubernetes allows you to do is effectively abstract away the cloud specifics and allow you to move between these clouds significantly more seamlessly. So that's another one of the drivers that we're seeing in organizations. And there's a few things I want to talk about as we go through that sort of bring us back to that portability and also the benefits that Rancher can give in that area. So developer-led. So developer leads who sort of discover Kubernetes, and I've been in this position. You discover Kubernetes and containers, and when you're sort of leading a team of people and you're sort of getting frustrated about the time it's taking you to do the release, then you can sort of use Kubernetes and containers to actually bring your devs up a lot quicker. So an example of this is people sharing an environment for doing deployments and doing development work and stepping on each other's toes. Actually, when you go into the container land, you no longer really need to do that, because you can actually have all of the system running on your laptop and running all of the services locally, and it sort of leads to a better development experience. It allows you to develop in a lot of different ways, so you can have different languages as part of your application and run them on the same server without any sort of clashes or anything. So again, I'll talk about that in a little bit more detail. And then, because the architecture team say so. So it's amusing the number of companies that we encounter where someone higher up in the organization has been to an IT or a DevOps conference, and they've sort of heard about this thing called Kubernetes, and they've come back and they've said, and this is what we should be doing. And it's been pushed down to the sort of the devs to then go away and implement it. This is not the sort of, it's not what sort of it sort of drives people. It's not sort of the best way of doing things. Typically, the developer-led ones are better, and they can push that up the organization. But actually, having this sort of push down and exposing people to this sort of this Kubernetes world is a nice way of sort of bringing people up to speed and getting them into the sort of the new way of doing things with containers and agile. Okay, so one of the first things that is actually surprising and surprises a lot of organizations when you go in and start talking about Kubernetes and containers is the size of the undertaking. I mean, what we're talking about doing here is actually significant. It's not just something that you can just implement in a week. It will take a huge amount of planning. So there's a whole new infrastructure stack. So there's the Kubernetes piece that sort of is brand new, and the management of those Kubernetes containers, so implementing something like Rancher, all of that bit's new. But actually, what you could do is you can actually look at how you actually provision your infrastructure and look at the things that you're currently doing and how you can potentially do them better. So most places, most large organizations have sort of a hardened image for their applications to run on. But when it moves across into sort of the container world, you actually lose pretty much all of the dependencies on the operating system, apart from actually being able to run a container on that operating system. So you can vastly simplify the way in which your servers actually run and significantly reduce the exposure and the binaries that sit on those servers that you then have to sort of maintain and patch going forward. So Rancher OS is an example of a great operating system that will allow you to just run containers, and it was designed just to run containers. But there are other alternatives out there that have been stripped down to sort of the bare bones just to run containers, and it's worth looking at sort of these infrastructure stacks and being able to take advantage of the benefits that they can bring in terms of the maintenance and the uptime and everything else. Changes required for the processes, so ensure the company's ready for it. This is sort of my last slide that I'm going to discuss, and I'm going to go into all of the areas that we typically enter sort of challenges with. So I'll go through those later on, but you have to be sure. So if you're in a company that's already doing agile, this is going to be less of a problem. But a lot of companies sort of have started doing agile as sort of Kubernetes and containers have come along, and it's quite a shock for the organization and can sometimes be one of the biggest challenges. So containers are a revolutionary change. They're not just an evolution. So going from bare metal to VMs was just really an evolution, because the way you did things was pretty much the same. You just had more operating systems that you had to patch and run with. The way that you do this with containers is it's completely revolutionized the way you do things. It's changed all of the practices and support that goes around actually maintaining and developing and deploying your application. And it's, like I say, it's not to be underestimated, the amount of sort of the amount of change that you're going to have to implement in the organization to actually take advantage of this. Now, I'm going to discuss a few ways where you can try and make this slightly simpler on the organization and sort of increase the positives of sort of implementing Kubernetes as well. And I'll go through that in a few slides. Like I've said, technology is typically the easy part. You can look on the internet, there's a whole sort of quarter of the internet that talks about how to adopt technology and how to implement technology, specifically around sort of Kubernetes and containers and how best to do this. And there's a lot of people have differing opinions, and there is sort of with Agile, for me, there is no real right necessarily. There's some very bad wrongs, but there's multiple ways to be right, and being pragmatic about the way that you do this is one of the things that you need to sort of bear in mind when you're starting this journey. If you try and do everything and make it all perfect, you will fail, because nothing works first time every time. But actually, it's a great way to learn, and sort of by making these mistakes, you can improve what you've done. I've never come across what I would term a perfect solution. I've come across a lot of solutions that are good enough, and there's some great sort of articles that sort of go into this stuff, but actually reading those, I found didn't really help me a huge amount. The problem that you have is every organization is different. The culture of every organization can sort of influence the way in which you adopt things, the way you develop things, the sort of the backgrounds of your developers can influence all of this. So just bear in mind, when you're actually going down this route, there's a lot of things that are going to potentially have to change. Okay, so first of all, I'm going to talk about the easy bit. So like I've already said, technology is easy. I haven't actually found anything that I haven't been able to containerize with a little bit of effort. The only one that I've not tried yet is something that uses a hardware dongle or as a specific hardware requirement, but I'm sure that it can be done. You just then have a dependency on hardware, which sort of goes against containers. But you can sort of containerize PKI, you can containerize databases, you can containerize basically any language that you want that's out there. Whether you necessarily should is a different question, but actually the technology part of this is pretty straightforward and pretty easy to do. So containers are what have made this easy. So Docker have made this really easy for people to consume. So the sort of the concept of containers has been around longer than Docker, but Docker made it consumable and have made it sort of a lot more digestible for enterprises and people. It sort of used to take some pretty heavy lifting to get stuff up and running and a little bit more overhead and maintenance. But now it's actually very simple to run containers in an organization. The next easy bit, I've never found a developer who hasn't enjoyed working with containers and basically never wanted to go back to doing anything any other way since moving to containers. When I joined Rancher, it was because I could see that containers were where everything was going to go, and they're a joy to work with. The frustrations of not having an operating system correctly configured because there's a dependency missing or there's a particular rule that's been set on the operating system that stops things failing, the days gone by now. Containers allow you to sort of take care of all of this easily, and you don't have to worry about it. Containers are just really easy ways of packaging your application and ensuring that they run the same every single time. And the other thing that's easy is replicating data centers. So as I mentioned earlier on, getting people running their applications on their laptops rather than having to necessarily share server environments where you've got 50 developers all fighting over a sort of a single box. Because sort of containers are very lightweight in comparison to having to run multiple operating systems on a laptop, it actually makes it really easy for devs. So again, this is another big plus for getting the developers on board. So the challenge for every dev is they all want a data center under their desk that replicates the environment that they're actually going to be finally deploying to. But actually, what this allows you to do is pretty much mimic the way that the data center functions, because you can be running on the same operating system, you're running the same containers, you can actually be running the same management sort of orchestration layer with Kubernetes, and also you can use Rancher as well locally on a laptop. It's lightweight and allows you to sort of move your containers around and monitor them, and it allows people to get used to troubleshooting with the tools that you're actually using in production. So the development practice becomes a hell of a lot easier. And it also has knock-on effects in that you've got testers who then can also run more scenarios because they don't have to have these specific environments set up. They can have their own containerized versions of the data sets that allow them to sort of use the application and test new versions of the application in isolation on their laptop without affecting everyone else. So it actually becomes really easy for sort of getting developers and the sort of the technical guys all on board. Okay, so K.I.S.S, keep it simple, stupid. This is where I find a lot of organizations try and bite off more than they can chew. So what you've got is start with a small app. So when you're looking at migrating your application into containers, start with something small and simple. And I'm going to go through a few more points that'll explain why, but it's like you can take monoliths, so huge monolithic applications, and containerize them if you want to. You will break a few of the best practices of sort of developing containers in the process, but you know what? It'll work. So you can do that. But what I recommend is getting your team up to speed and getting an understanding of the benefits that containers can give you before you actually start trying to tackle these larger applications. So I've seen companies where they've actually developed a dummy app just to basically get their developers used to Kubernetes and containers and understanding how they sort of run forward with this stuff. One of the great things is it doesn't matter what the language is. So if your application exists in Java or it's C or C# or sort of Node, Python, whatever you want, it can all be containerized now. And you don't have to restrict your sort of developers to any particular language. They can now sort of code in their language of choice. I'm not saying that's necessarily a good idea, and it's always good to have standards. Otherwise, you'll have a headache trying to recruit new developers and understanding the code when the only person who's written Python leaves. But you then have freedom to develop in different languages, and you can have different parts of your applications running in different languages if you want to. The first app that you tackle should be simple and stateless. And it's not that you can't use state. We know you can use state within Kubernetes, but actually getting people used to developing and running simple stateless apps, it sort of gives them then the grounding to then go on and sort of bring in the more complex scenarios. So when people start with containers, there's a learning curve that comes with it. How do you develop the containers? How do you compile the containers? How do you move the containers around and store the containers and all the rest of it? And then if you've got to then learn Kubernetes on top of that, it can become exponentially more difficult to understand how to orchestrate these things. And understanding sort of how to best do things can take a little bit of effort. So it's actually easier if you've got a simple app that you can easily troubleshoot. It allows people to sort of get used to the technology and the processes and everything else without sort of having to troubleshoot the problems with the actual application at the same time. Migrate it as is. Like I said, you can do migrations of monoliths if you really want to, but if you've already got an application that's in sort of microservices form, you don't have to migrate everything in one go. You can migrate certain parts of the application, so they can still communicate out to the outside world, and you can still communicate into these applications. So just move part of the application out if that sort of is the best way for you to gain adoption within the organization. Don't try and do everything all in one go. Just try and keep it simple. Clearing the gates. So this is sort of one of the things that again leads on to my last slide, and it's about the hard bits. So whenever you get a new technology into an organization, the difficult bit is always the process of getting it released. So how do you put in place all of the things that you need to get from actually developing a piece of code to actually running that code in production? So what I've found is that organizations that have a simple application that they use to clear the gates and sort of develop the processes, it makes it a lot easier because typically a lot less departments will scrutinize it. So if you choose something that's sort of almost irrelevant to the organization, but it actually clears the gates, then you will you'll sort of reap benefits from it in the long run. So Ignoring dependencies and sort of other things that it depends on is sort of a nice way to keep it simple, but actually just moving part of the application, provided it's not too sort of complicated, it just makes it sort of a lot simpler to get this process adopted within the organization. Okay, storage. One of the biggest questions we get, and I can speak for all of field engineering on this, is around storage. It's a masterclass in its own right. There's so many variables and so many questions and so many different use cases that it's actually really, really difficult to sort of give great advice. No, it's great. It's easy to give great advice. The problem is there is no silver bullet for this. There's a lot of variables that need to be analysed as to what suits, and you need to understand why you're doing something and what you're expecting something to do in order to determine what the best the best solution for implementing storage is. One of the things that I always look at is primary source or secondary source of data. So what I mean by this is the container going to contain a primary source of data, i.e., does it only exist within the container? If it does, I usually try and push people away to either storing that somewhere else or having a really robust backup strategy. I think containers are fantastic for doing secondary sources of data, where what they're doing is effectively caching and building up data sources from other external data sources. And with this, you don't have the considerations of storage, because actually you don't really care whether the container sort of survives or not, because you can actually rebuild that data. Now, there's obviously consequences of doing that. Potentially it's time, potentially it's hits onto the back-end data source. But there's a lot of things that you can consider when doing storage. So my sort of recommendation is, try and keep storage to a minimum. Try and consume storage from sort of existing data stores if possible. Again, it will help clear the gates. It will make it simpler, and it will stop sort of as many people scrutinizing your processes for getting through to production. Only then, when you've got that process sort of nice and sort of oiled, then start introducing the additional complexities, and it's a slightly easier fight when people have seen the benefits that actually containerization does for the organization. Exposing applications. So this is where, if you've got applications that sort of sit within the sort of the Kubernetes bubble, as it were, you need to poke a hole in order to expose it. So there's a number of ways of doing this. You can use an ingress, where effectively you stick a load balancer on front of it, or a node port, where you expose a port on a server that exposes a service that then points towards your application. There's a number of ways of doing this, but the things you need to consider are what's going to be consuming the app. How sort of, is it just something where you've got a front door, you come in, everything's running within your sort of Kubernetes, and then it goes out again? Or actually, is this an API that lots of other things need to call, and you're running different APIs within there, and you need to expose them all? So understanding what your application requirements are up front really will help in sort of easing what you do with this and how you expose the apps. It's very easy to expose applications under Kubernetes, and so there is no real right solution necessarily, but there are multiple solutions out there. The other thing that has to be considered is security and SSL termination. So a lot of applications tend to run within the Kubernetes bubble without any sort of secure sort of authentication between them. A lot of people are doing clear text, because everything's sort of encompassed in an overlay network, and if you're running on top in a secure data center, you don't necessarily want the overhead of sort of the encryption and decryption at every call. So you can do SSL termination at the edge, or if you sort of want a really secure solution, you can do SSL termination at every service layer. Again, just something to think about. For going through for your first lot, I would try and keep it simple. Do SSL termination on the edge. It's really easy to set up, and it makes your life a lot easier. It also makes debugging the application slightly easier, because you can do network captures and actually read the code that's going through. Okay, services versus servers. So like I said, it's revolutionary really what you're doing with containers, and the way you do things is very, very different. Containers don't sit still. Containers move. 1 minute they can be on one server, the next minute they could be on another server. So people who are coming from enterprise backgrounds that sort of have got their change management database that has the name of a server and the application that is running on that server and all of the services that affects if that application goes down, they don't really work. It's very difficult to monitor something as dynamic as containers can be. And so the flexibility for containers comes from the way that it is dynamic, and you effectively become almost agnostic to what you're running on. You don't care sort of where the server sits, provided there's enough resource and compute power to actually run the container. It could be sitting anywhere in your compute cloud. So it's not quite the same in the way that you have sort of a monitor on a server. You monitor services now because you care more about it. So static monitoring doesn't work. So it does for some things. So obviously the servers that you're running your containers on, they can work with sort of your traditional monitoring solutions where you give it an IP address, it goes away and installs an agent and allows them to sort of get diagnostic information back about the server. But what you want to do with sort of the monitoring is it needs to be a little bit more dynamic, and there are some solutions that are out there. There's sort of container native and cloud native solutions, and they can do monitoring great. But with the servers as well, when you move into sort of Kubernetes and containers, typically your servers aren't static anymore. You don't procure servers in the same way and have the same lead time to provision a server. What you do have is a sort of a huge cloud of computing that's available to you that can expand and contract on demand. So again, sort of whilst the static monitoring will work to an extent, there's actually better ways of doing this, and using cloud native solutions for monitoring the infrastructure that it's going to be working on it is sort of a nicer way. Deep ping through a service. So this is what I was talking about, where because you can't monitor the servers, what you actually want to do is you want to check that your service is actually up and running. So you have less of a sort of a dependency on a particular server going down and losing sort of a portion of your service, because the way that you work with containers is there are typically multiple containers that are running that service. So if you lose one of the containers, you may affect the response time and the responsiveness of the application, but the theory is it actually shouldn't affect your application other than being slightly slower. So what a lot of organizations are doing now is when they're developing the servers and sort of monitoring the services that are sort of working, is they actually do deep pings through the service. So they'll have calls within the application that allow them to do synthetic transactions from start to end and ensure that it touches on each part of the service as it is running, so that actually you only raise a red alert when actually all of that, the sort of the instances of a particular portion of the service have gone. You can have an amber alert when it's not running at scale, but actually Kubernetes is very efficient at bringing things back up when things fail and moving them around. So hopefully it's only going to be a minor interruption of sort of service. So a hardware failure in sort of a Kubernetes cluster doesn't have the same effect as sort of a hardware failure on a server that's running a key portion of an application, just because of the way that everything's containerized and it all moves around. Okay, so this has just been really some pointers on how to sort of take the sort of Kubernetes journey and some of the common things that we encounter. Now I'm going to talk about the hard bits. So these are the bits that every organization, every enterprise organization that we go into struggles with. So first thing is operations. So what you need to do with operations is you need to get them on board early. Because of the sort of the size of the change, typically the way that they do deployments will change, the way that they may monitor things will be changing, and you can't just expect all the devs to complete all of their work and get this service into production and then throw it over the fence to operations. There's very few large organizations that we go into that actually run a true DevOps type organization. A lot of them still have a dev and an ops split. So getting operations involved early, getting them sort of playing with the sort of Kubernetes and the management portion of the application and sort of the management side of the containerization is actually really important. Getting these guys on board is sort of one of the key things to making this a success. If you don't involve these guys, these will be the guys who pretty much have a final say in whether or not something will go live, because if they can't support it, you won't be going from development into production. So getting these guys on board is actually a really important thing. Procurement. Less important in organizations that are already consuming subscription-based applications and services, but a lot of sort of larger enterprises, when they're running with this sort of containerization strategy, they're doing this alongside the introduction of sort of agile development practices and things. And procurement used to having something physical to show, a license key or a physical server with an asset tag. It's more difficult if you can't get procurement on board with sort of things like open source. Well, open source doesn't require any cost, so why do procurement need to be involved? Well, it actually has quite a significant cost. And the first thing is that you'll still need servers to run this stuff on, and typically these will be cloud-based servers that can be sort of scaled up and scaled down. So procurement need to get their heads around the fact that their bill won't be the same every month. It can go up and it can go down, and it can make a lot of difference. So actually getting procurement involved early in this process will help sort of creating sort of the gates, opening the gates for you to be able to sort of procure services that sort of are subscription based. So you buy support contracts for open source software. You buy elastic compute capabilities where it can grow and it can contract depending on demand and depending on how successful a product launch is. So getting these guys on board is sort of one of the key things that you need to do. Change and release management. They're another sort of one that can basically block you in your tracks. If you don't have a robust sort of process for doing your change management and release management processes, you'll get shot out of the water. In some ways, Kubernetes can make this easier. So in instances where I've implemented this in the past, it can be easier purely because people can now sort of roll back to something that doesn't require someone to actually make changes to a server. So it may be in the past to actually upgrade your application, what you did was you ran some sort of change management, release management type orchestration, Ansible or Chef, Puppet and stuff, and that went onto the server and made changes and did things. In between that, they might have upgraded the operating system, and that can have an effect on your application. Actually, with containers, because you can respin up your application in the same state it was before by purely redeploying the old version of the application, because it has no dependencies, they're all contained in the actual container itself. It can make these things easier, but you need to get buy-in from these guys. Otherwise, again, you'll be on a hide into nothing. And the last one I want to talk about is security. So getting security involved early is sort of, again, it's critical to getting these things through into production. The way that containers communicate is different. They may be used to firewalls between every single layer of your application, and they want audit logs left, right, and center. And it's a lot more. It's possible within containers, but it's not really best practice within containers. So there are security products out there that are specific to containers that can give you some of this and give you the sort of the granularity that you want, but it removes some of the flexibility of the benefits that containers give you. So again, getting these guys involved early is a great thing to do, and it will sort of ease the path through to production. So that's the end of my slides. So Anka, is there any questions that we wanted to go through?
Hi, Chris. Yes, there are actually a lot of questions, and I have assigned quite a few of them to you because I think they make a lot of sense. A lot of these questions are about what is ranchers. So I was thinking if you could give control, then I can quickly cover that.
Yeah, sure. Just give me 1 second. I'm going to figure out how to stop sharing. There you go. And I've made you presenter again.
Thank you, sir. And let me try to get it. Okay. Can everybody see my slides, which says Rancher is an open source container management platform?
Not yet.
Oh. My apologies. Let me try to do that one more time. Okay, I am unable to take control from you, Chris. Maybe we can just answer the questions then.
Yeah, sure. So if I go through the ones, am I just going through the ones that have been assigned to me?
Yes, please.
Okay. So considering Ranch is free, do you have any sales or support team? We're looking to compare which tool to use and get some support. Absolutely. So Rancher monetizes by selling support contracts to organizations. We do sort of an in-depth support. So we support not only Rancher, we obviously support Kubernetes that is running as part of the Rancher deployment. We'll also support any applications that we embed as part of Rancher. So this includes sort of Prometheus from when we introduce it integrated into 2.2 and the other applications that we have in there. And we do sort of root cause analysis. So we'll go right down into the Kubernetes, even if it's not our own Kubernetes, and we'll sort of help you troubleshoot what the issue is. Now, obviously, we can sort of fix issues if it's anything to do with us, but we can point you in the right direction if it's something that you're going to have to go away and fix with either another provider or with your own code. So yeah, we do have support. I'm sure we can sort of Matthew or Anchor can take your contact details and we can put you in touch, or you can actually go to the rancher.com and there's a support request and an inquiry on their form that you can fill in and fill that in, and someone will be in touch. So thank you for the question. Okay, Anchor, you're now sharing your screen and Slack.
Oh, my apologies.
Okay. Do companies typically keep stateful applications like databases outside of Kubernetes? Is it best practice to have a database for each service or a database for all related services? And that's come from Hang. It really depends on the organization. But what we're finding is that most places, yes, typically they are keeping databases outside of Kubernetes. I sort of still recommend that sort of databases sit nicer outside, purely because of the way in which sort of DBAs exist as a whole entity themselves, and they do performance tuning and they optimize the hardware and the operating system to such an extent to make the sort of databases perform optimally. When you're running within sort of Kubernetes, effectively you're putting everything onto a generic platform. So all of your OSs should be the same. They can be different, but for consistency, you want to keep them the same. But they're not necessarily tuned for I/O in the same way that a database sort of hardware layer is. So yeah, I would say most companies. There are some companies that are doing sort of cloud native type database technologies. So if you're doing things that can do sharding, so it automatically self-replicates the data, then yeah, you can get advantages from doing that. But typically, most enterprises that we're dealing with are still leaving their databases where they are and just consuming data from them by the services. Okay, what kind of apps fall under the best use case category of migrating them to Kubernetes? And that's from Naveen. Simple stateless apps are actually the best use case because it's what really containers were sort of originally intended for. They've been mangled to do other things, but actually the great thing about containers is that they have the flexibility to be able to do that. So anything that's sort of microservices where it doesn't sort of contain state is the apps that I sort of say will work nicest. They're the ones typically that can sort of scale nicely and sort of don't have issues. Some depending on what the application is, if you've got sort of an application that's storing some sort of session state for a user as part of its process, again, that can be problematic, because if you lose the server that's got the or lose the container that's storing that session state, then it can reset everyone. But it's normally more of a minor inconvenience than actually taking out your application. So yeah, I mean, simple stateless apps are what they're best designed for. So I'd go with those. But like I say, you can sort of mangle it to pretty much anything you want to do. Okay, so regarding storage, if the choice is between AWS K.I.S.S versus running a storage set deployment of Confluence Kafka Helm chart, you'd suggest AWS K.I.S.S as a starting point. And that's from Chad. I've not got any experience of it, but if it's a sort of a hardware-backed storage solution, it depends on what performance you can get from it. It depends how it's going to integrate with your actual containers. So Kubernetes has sort of the cloud native awareness. So when it's running in AWS, it's aware of EBS volumes and things. So potentially it can, if it's sort of a storage set. I don't, like I say, I'm not sure what it is. I don't know if it's some sort of service that will store things. But yeah, possibly it's the best way of doing it. But with everything storage wise, I always recommend that people do a proof of concept. And if the performance and everything is a real sort of issue that people have, then benchmark it. Ensure that it fulfills your need. And it's the same with pretty much anything that you do within Kubernetes. Whichever ingress you go with, ensure that it's fulfilling the need that you actually require it for. Otherwise, it's going to cause you heartache along the way. Okay. Can you manage your OpenShift container platform cluster with Rancher? Currently, you can't. It doesn't currently import OpenShift clusters. We can import basically any other cluster, so we can sort of help with EKS and AKS and anything that you've stood up with Kops or KubeSpray, but currently we don't do OpenShift. So that came from Afan, so thank you for the question. Let me find the next one.
Chris, whenever you like stopping, just hand it back to me.
I've not got anything. You've got, that is your screen that you're sharing.
Yep. Let me just run through. One of the common questions that we received was about what is Rancher, and then I think there was a lot of confusion if Rancher manages Kubernetes or Rancher does something else or it's part of Kubernetes. So let me just quickly run through that, and I think that will answer a lot of questions that are still outstanding. So if you're not familiar with us, I will highly encourage you to check us out at www.rancher.com. And in a nutshell, Rancher is an open source platform for deploying and managing your enterprise-grade Kubernetes at scale. We have a huge community. We have downloads that run in millions, maybe even over 100 million by now. And our products have been adopted by thousands of enterprises worldwide, either in open source fashion or those who become sort of our supported customers. So the question really is, why is Rancher so popular? And the reason is that unlike many other container management platforms, Rancher provides multi-cluster Kubernetes management, which means you can import your Kubernetes clusters from anywhere. You can create them on any cloud, just as Chris was mentioning, or you can create them using Rancher, and obviously, and then you can manage all of them from a single pane of glass. And when we say managing multi-cluster Kubernetes, we basically mean three things. Number one, using Rancher, you can create new clusters within seconds on any infrastructure or a cloud service of your choice, and that includes like EC2, VMware, bare metal, EKS, AKS. Then second is cluster management itself. What does it mean? And the answer here is that you can stand up a Kubernetes cluster today. It's not too hard. You can do it yourself, or you can do it in an automated way using a bunch of tools. Once again, Chris mentioned some of them like KubeSpray. So standing up a Kubernetes cluster, it's not too hard today. A lot of people can do it, and they can do it rather easily. What Rancher makes it easy for you to do is to basically, it slaps a UI on top of that, which is very user-friendly. And then it makes Kubernetes management a breeze. You get authentication, RBAC, policies, security, logging, monitoring, auditing, all these capabilities for free with Rancher, like when you deploy Rancher. And then workload management. Once the reason why you're doing all this is because at the end of the day, you want to deploy some containers and you want to manage some apps. That's purely the reason why you have brought up your Kubernetes. And what Rancher can do is that we basically give you a catalog where you can deploy Helm charts, or you can pull Helm charts from. We have inbuilt monitoring, like I said, logging, auditing, policy management, CI/CD. So all these things which makes deploying your application and managing your application in runtime extremely easy for you. And you can enable most of these things with just a single click. So once again, I encourage you to check us out at www.rancher.com. So I spoke for like a couple of minutes. I will recap. And the recap here is Rancher allows you to create new clusters or import existing clusters into Rancher, manage these clusters from a single pane of glass UI, and then deploy and manage workloads on these clusters very easily. We always are adding new capabilities. In fact, if you go and check us out right now, we have introduced a really cool capability. It's called multi-cluster application. And what happens here is that you can deploy one app. You can choose an app that you're deploying. You can choose as many target clusters as you want. You can do a little bit of configuration, push a button, and that app gets deployed on all of these target clusters. And you can choose to deploy them simultaneously. And then you can even decide how to upgrade this app on all these clusters together. Like either you can do a rolling upgrade, or you can do a simultaneous upgrade. So with Rancher, you get all of this. And if that's not enough, it's completely open source. That was another question that, are you open source? Are you free? Or what do I have to do to get started? Well, it's completely open source. We don't have an enterprise version. We don't have a community edition like many other people do. Everything that we do is open source, so it's there for you to use. Start using it today, and as you grow, you can continue to grow. Once again, you don't need much. You can just continue to use open source software, and then at some point of time, if you deploy it in production, some customers choose to kind of come to us and ask us for support, and that's it. But I think that takes care of like 10 or 20 questions that we received on the chat about whether Rancher is open source and free or not. And that's it. That's all I had. And if you want to get engaged and learn more, I already spoke through this, then here is a quick start guide. You can just go to rancher.com and go to our learn page and then start docs, and you will basically figure out everything. We have a quick start, we have detailed docs, everything. So all you need to remember is rancher.com, and then from there it becomes very easy to get further information. If you are ready, you want to go and deploy Rancher, you can check us out on GitHub. You can see what's happening. You can check out the issues that are open. If you want to learn more about Kubernetes, we blog a lot. We blog a lot about Rancher. We blog a lot about Kubernetes. Here is a blog about a multi-cluster application, which I wrote. So one application, any target cluster sitting on any cloud, you can just point and shoot, and it basically just goes and gets deployed over there. So that's an example that we picked over here. We have a Slack. If you want help, if you want to join the community, ask each other questions. Think of it as an easy way for you to learn more and learn more from your peers. So just come and join us on Slack, and you can check us out on forums, of course, and learn much more about that. That's about it. If there are further questions, I'll be happy to answer. If not, then we can stop and give everybody a few minutes back. Let me open up my questions and see if there are any I could. Oh, there are much more. I'm not sure if you guys can see this.
So there's a few I'll pick up, Anka. One from Florita. Can you speak a little bit as to the different timelines that you've seen? So timelines from going from no Docker and Kubernetes to Docker and Kubernetes, and standalone Docker to bring on Kubernetes. It's sort of a piece of string, unfortunately. It depends on the culture of the organization. It depends on the complexity of the application. We've seen some organizations literally go from having nothing, but they've already got a microservices architected application, through to actually deploying into production clusters within a matter of months. Technology-wise, typically you can get it going within a week, but like I say, it's the gates that typically cause the problem. So actually getting something into production and getting support and everything in place usually takes the time. So if you've already got Docker in but aren't necessarily using Kubernetes, it's typically a lot quicker because containers are portable between different orchestrators. So actually porting to Kubernetes is relatively straightforward to do. You just have to redefine how your application sees the rest of the application, but it's very simple to do. So in those instances, it's pretty easy to bring the application through from sort of standalone Docker to running on Kubernetes.
All right.
Someone asked something about, but we do have a masterclass coming later in the series around troubleshooting. So that'll be troubleshooting. I think it'll probably cover some application troubleshooting, but primarily talking about troubleshooting Rancher and sort of Kubernetes. Okay.
Chris, there is a question about global DNS. I think I can quickly take it. Speaking of clusters, I'm curious to know how to implement a global DNS across multiple clusters. We have a new capability that we are going to announce very soon, and that allows you to do exactly that. So with multi-cluster applications and global DNS, we think we can make high availability apps a reality, and it's going to happen within weeks, not months. So please stay tuned, check us out again. In fact, if you try to download our 2.2 preview 2, then you should be able to use global DNS right now. It's in experimental like alpha stage, but you should be able to use it. There is a question. The picture implies that every team has their own cluster. Do you support multiple teams sharing cluster via namespaces? Absolutely. Rancher does not alter Kubernetes in any way. So if you deploy Kubernetes in a single cluster mode and you just want to manage one cluster and give different namespaces to your team, absolutely, go ahead. It's your Kubernetes cluster. We just make it very easy for you to manage and add RBAC, and we have a concept of projects that's a higher level abstraction on top of namespaces. So that kind of gives you the isolation that you don't get from Kubernetes as is. But just to answer your question again, yeah, absolutely. Please go ahead and use it exactly the way you are describing. Create namespaces for different teams and use one cluster. Do we still have more time, Matthew? Chris, want to answer a couple of more?
A few more minutes.
Okay. Chris, one for you. I read from Kubernetes on VMs many times, also in your slides. Isn't it easier to provide some bare metal servers for this? Actually, I don't understand the question.
No, I'm not sure either. If we had clarification, I could. So, I mean, bare metal servers can be used. So you can add bare metal servers. So typically what people do is etcd in the control plane typically require less sort of compute resource. So most people run those in VMs, but actually if they've got some applications that are sort of are very heavy on CPU or very heavy on RAM, then you can use bare metal servers for the worker nodes that run your actual application. So most places that we go to, you find that if they're running on-prem, they'll be doing mix and match between VMs and bare metal.
Okay. So Chris, one more question. This may be of interest to you. It relates to the topic directly. Could you share details on how to do troubleshooting if an application after migration, and where to look for? So I think the question really is, after you have migrated to Kubernetes and something goes wrong, how do you go about troubleshooting that app that is now running on Kubernetes?
Yeah, so we are. I did say we've got a masterclass coming up on this around troubleshooting. So, I mean, typically you'd be looking in your application logs. If it's not in your application logs, then you'd be looking at the Kubernetes logs. So, looking at the logs of the kubelet, looking at the logs of the network and the API server to see if you can figure out what's sort of happening with the application. So, it could be erroring because of things like memory, or there's no disk provision and it's expecting a dynamic disk provision. There's a huge number of sort of errors that it could be, but it's usually relatively easy to find if it's a simple-ish thing to find out why. So more often than not, the issues that I've seen where people have migrated their applications into Kubernetes is it's actually an application issue rather than a Kubernetes or scheduling issue. So it may be that you've not parameterized something within the application. So this was another common one where the actual customization of applications when they're running in containers, so using things like config maps or using another tool to actually personalize the containers, you've missed part of the files that need to be templated, and you've got it hard coded to something that was in your old infrastructure. That's quite a common issue that people run into when migrating applications from sort of a standard server stack to containers. So actually getting your head around the customization and how you inject that data at runtime and make it so it can sort of pick up the rest of the services is another sort of one of the technology bits. There's a few solutions out there that they work very well, but it's actually going through and making sure that you've sort of parameterized the application correctly.
Wonderful. Thank you very much, Chris. Thank you, Matthew, for supporting us. And thank you, everybody, for joining. I hope this was as useful to you as you expected. I have brought up the screen, which lists some of the upcoming classes in this series. We run one every week. If you go once again to www.rancher.com, you will find links to a page where we list all the future classes that we have already planned out. And as Chris mentioned, one of them is going to be about troubleshooting. Thank you very much, and I hope to see you all again next Tuesday. Bye-bye.